Hello everyone, welcome to my channel Chemistry with Manali. So this is my first video on my channel. So what we'll be trying to do through this channel is we'll try to make chemistry as easy and as joyful as possible. So to understand chemistry and its concepts better, the first and the most foremost thing is to understand the concept of electrons, protons, neutrons, electronic configuration of elements and their valency. So these are the things which makes the foundation of chemistry stronger. So today, as this is the first video on this channel, we'll start with the very basics of chemistry. We'll try to understand the structure of an atom. We'll try to understand how the electrons are arranged in atom. We'll basically try to understand the layout of an atomic structure. So let us begin. So an atom is the smallest particle of matter which cannot be seen with the naked eye, and an atom has three fundamental particles. The first is the electron, second is the proton, and the third is the neutron. So electrons are negatively charged, denoted with the negative sign. Protons are positively charged, and neutrons are basically chargeless. They are neutral species. So in an atom, we'll try to understand how these fundamental particles are arranged. So let us see the arrangement of these fundamental particles. For example, this is an atom. So in the center of the atom, here the protons and the neutrons will be present, right? And the electrons will be revolving around the protons and neutrons in circular orbits. So these circular orbits are called shells, and the protons and neutrons, they rest in the nucleus. So the center of the atom is called the nucleus. So the nucleus consists of the protons and neutrons, and the electrons will be revolving around the nucleus in circular paths which are called orbits. Now these circular paths may be denoted as orbits or shells. The first shell is denoted by K shell, the second shell is denoted by L shell, third shell denoted by M shell, fourth shell will be denoted by N shell, and so on and so forth. So this is the basic layout of every atom. This is how the electrons will be arranged in an atom. Now, what is the maximum capacity of the shell for accommodating an electron? For example, we cannot accommodate n number of electrons in a shell. Every shell has a maximum capacity of accommodating electrons. For example, the first shell, that is the K shell, can accommodate a maximum of 2 electrons. You cannot accommodate more than 2 electrons in the K shell or the first shell. The L shell can accommodate a maximum of 8 electrons. You cannot exceed 8 electrons in the L shell. Similarly, the M shell will accommodate a maximum of 18 electrons. So this is how electrons will be accommodated in the shells. Now this can be put in a very general formula, which is 2n square. If you use this formula, n being the number of shell, you can calculate what is the maximum number of electrons that can be accommodated in a shell. For example, for the K shell, n will be equal to 1. So 2 is the maximum number of electrons in the K shell. Now for the N shell, L shell, n will be 2. So it will be 8. So this is the maximum capacity of L shell. Now for the third shell, n will be 3. That is 18 electrons. So this is how electrons are accommodated in the shells. Now let us consider specific atoms of an element and see how they will be arranged. Okay. Now let us consider the first 10 elements of the periodic table: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, these are the first 10 elements of the periodic table, and their atomic numbers are: this is 1, this is 2, 3, 4, 5, 6 and 7, 8, 9, 10. So these are the atomic numbers. So what is the atomic number of an element? Atomic number is the number of protons that an element will contain. So number of protons is always equal to the number of electrons in an element. So atomic number is equal to the number of protons or number of electrons in an element. So if the number of electrons in hydrogen is 1, so its electronic configuration will be 1. Electronic configuration denotes how the electrons will be arranged in the element. So this 1 electron will be arranged in the K shell, in the first shell. So for atomic number 2, the electronic configuration will be 2. That means 2 electrons will be arranged in the K shell. Now for the third element, lithium, where the atomic number is 7, the arrangement will be 2.1. Why is it so? Because the first shell can accommodate a maximum of 2 electrons. So the third electron will go to the next shell, that is the L shell. Beryllium, atomic number is 4, arrangement will be 2.2, because first shell can accommodate a maximum of 2 electrons. So for your reference, let us see the structure so that it becomes easier for you to accommodate the electrons. So this is the nucleus where the protons and neutrons will be present. This is the K shell, this is the L shell, this is the M shell. So for hydrogen, since atomic number is 1, 1 electron will be accommodated in the K shell. For helium, atomic number 2, 2 electrons will be accommodated in the K shell. Now the K shell is already full. Now it cannot accommodate further electrons. So the next electron will go to the higher shell, that is the L shell. For lithium, it is 2.1. So 2 in the K shell and the third electron goes to the L shell. For beryllium, 2.2. 2 electron in the K shell and the remaining 2 in the next shell, that is the L shell. Now for boron, it is 5 is the atomic number. So configuration will be 2.3. So 2 electrons in K shell and 3 in the L shell. For carbon, so this is the way how you arrange the electrons in the shells. Carbon is 2.4. So 2 in the K shell and 4 in the L shell. Nitrogen will be 2.5. 2 in the K shell, 5 in the L shell. Oxygen 2.6. Fluorine 2.7. Neon is 2.8. So now the L shell is full. It cannot accommodate further electrons. So after neon, when the atomic number is 11, that is for sodium, now we will go to the next higher atomic numbers, which is number 11 is for sodium, 12 magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium. So for the atomic number 11, the arrangement will be 2.8.1. For sodium, where atomic number is 11, this is the arrangement 2.8.1. 2 electrons in the K shell, 8 electrons in the L shell, and now since the L shell is full, the 11th electron will go to the next higher shell, which is M shell. For magnesium, it is 2.8.2. So 2 in the K shell, 8 in the L shell, and next remaining 2 will go to the M shell. Aluminium is 2.8.3, silicon 2.8.4, phosphorus is 2.8.5. Now here so in the previous discussion we have discussed that the third shell will have a maximum of 18 electrons as per the formula 2n square, but there is an exception here which we will be discussing in the later part. So here we will be considering that the third shell will have a maximum of 8 electrons. So since the third shell is full, the next electron will go to the N shell. So the configuration of potassium will be 2.8.1, and for calcium it is 2.8.2. So this is how the electrons are accommodated in the elements or in the various circular orbits or shells. So from this configuration, the next discussion will be on valency, which forms the foundation of chemistry to understand reactions better, to understand the concepts of chemistry better. This is the first basic concept, and then in the next part we will be discussing valency based on today's discussion. So thank you all. If you like this video, please like it and subscribe to my channel. Thank you.